Okay, so this first unit talks about everything about polynomials, and it's pretty important to understand every part of it. Okay, so first off, we have to discuss a term. A term is a coefficient and variable linked by multiplication. Okay, so when we look at it, 3x is a term. Okay, now a polynomial is a bunch of terms, right? Um, linked by addition and subtraction. So when we see this, like a bunch of terms, right, we're talking about like 3x squared is a term and so on. So example of a polynomial is if I had like 3x squared plus 8x minus 3. What you have to understand is each of these represent a term. The things linked by addition and subtraction are your terms. So when you're reading the directions in a homework assignment, it's important to understand the vocabulary. So a monomial is a polynomial with one term. So an example of this would be 4x squared. There's only one term and one term only. Okay, a binomial is a polynomial with two terms. So one example of this would be like x plus 5. Right now I have one term, two terms. Now another example would be like 6x squared minus 3, right? You have two terms linked by subtraction here. Now a polynomial or a trinomial is a polynomial with three terms. So an example of this would be like x squared plus 6x minus 3. Okay, so anytime you see in the directions, factor the quadratic trinomial. When you see the word trinomial, you know it has to be a polynomial with three terms. Okay, so if we had to classify the following polynomials by the number of terms, if I look at the first example, we have 1, 2, 3 terms. Okay, so this has three terms, and a polynomial with three terms is a trinomial. Okay, the next example, everything's simplified, and if I look, we have 1, 2, 3, 4 terms, and anything we go over 3, we just call it a polynomial. So this has 4 terms, so it's a polynomial. Example 3, you have 1, 2 terms, therefore it's a binomial. And the last one, there's only one term, so this would be a monomial. All right. So knowing these terms is very, very important. Now, the standard form of a polynomial is a polynomial written in descending, right, exponential order. The degree of a polynomial, right, and this is key here, the degree of a polynomial is the largest exponent when the polynomial is written in standard form. And the leading coefficient, right, if I look at it, the leading coefficient is the coefficient of the term with the highest degree when written in standard form. Basically, it's the number in front of the first term. Now remember, when we talk about these terms, right? If I look at something like ax squared, a would be the number in front of the variable expression. So this would be called the coefficient. X is the variable, and the highest exponent or any exponent is considered the degree of the term. Okay, So when we talk about a degree 0 polynomial, this is basically a constant. It's basically a number without a variable. So anytime we refer to the constant, it's a number without a variable attached to it by multiplication. Degree 1, all right, we call this linear. Okay, and when we talk about degree 1, your variable expression is technically raised to the first power, but a lot of times you'll just see the variable with no exponent. So an example of a degree 1 polynomial, right, would be 3x plus 5. All right, if I look at this, that x term being the highest exponent would mean it's linear. Degree 2 we call quadratic. That's when the highest exponent is 2. And an example of this would be 4x squared minus 3x plus 2. If I look, the highest exponent is 2, which makes it a quadratic. And if it's a degree 3, right, we call that a cubic. And the highest exponent here is 3. So an example of this would be like 5x to the third plus 2x minus, say, 1. So the fact that the highest exponent in this problem is 3 makes it a degree 3 polynomial, and we name that a cubic. Okay? So the first example says, write the expression in standard form, classify the polynomial by the number of terms and the degree, and state the leading coefficient. So standard form, we always want to go highest exponent to lowest exponent. So the first one, right, that's the highest exponent. So we're going to write, since it's got a minus sign in front, we're going to say negative 10x squared plus 12x plus 4. I go degree 2, degree 1 constant. The name by number of terms, since there are 3 terms, we're going to call this a trinomial. The name by degree, since it's degree 2, we're going to say it's a quadratic. And the leading coefficient, when I look at the standard form, what's the coefficient of the first term? That is negative 10. So the leading coefficient is negative 10. Okay. So the next one, standard form. 3 is my highest exponent, so I'm going to write that term first. 2 is the second highest, so minus 2x squared. X is the next one, so minus 7x, then plus 5. Since this has 4 terms, we're just going to call it a polynomial. And the name by degree would be a cubic, because the highest exponent is 3. Now the leading coefficient, what's the number in front of the highest degree variable expression? That would be 8. Okay, so if I look, my leading coefficient is the number in front of the first term when written in standard form. All right, so real quick, pause the video, try the next few examples, and then come back and check your answers. So the first one, standard form is just 6. It's the only term. Because there's only one term, it's a monomial. And the name by degree is a degree 0, right? So we call that a constant. And the leading coefficient is just 6. The next one, if I write in descending order by degree or exponent, I would write 8x squared first, then minus 3x, then minus 7, and the name by number of terms would be a trinomial. The name by degree, since the highest exponent is 2, we're going to say it's a quadratic. And the leading coefficient would be 8. All right. Next one, you have 8m squared plus 3x to the third minus 6x plus 7. Standard form, highest exponent is 3, so 3x to the third. Then we go m to the, oh, that should be x, sorry. Then we're going to go plus 8x to the second, then minus 6x plus 7. The name by the number of terms would be a polynomial. Name by degree, since the highest degree is 3, we're going to say it's a cubic. And the leading coefficient would be the number in front, which is 3. All right. And the last one, standard form, highest exponent would be 5x and then minus 10. The name by the number of terms, there's 2 terms, so it's a binomial. Now the name by degree, right now you don't see it, but the degree or the exponent is 1 on the x term. So we're going to say it's a degree 1, which is linear. And the leading coefficient would be 5. Okay, so being able to identify a polynomial by the number of terms and the degree is important for reading the directions of many problems that we will deal with. So what is the difference between classifying a polynomial by degree and the number of terms? Degree looks at the exponent, and the number of terms looks at the number of terms linked by addition or subtraction. Okay, so let's look at the checkup problems here. 1, which of the following are monomials? Select all that apply. Okay, so when I look at it, how many terms does this polynomial have? 1. So A is a monomial. B, right, if I look at B, that is 2 terms. So this is a binomial. So that is not a monomial. Anytime a variable expression is is in the denominator of a fraction, it doesn't count. So that's not a polynomial. This here, 14, that is a constant and a monomial. The next one, in order for it to be a polynomial, your exponents have to be positive because the exponent on x is negative. That is not a polynomial, which means it cannot be a monomial. So when I look at the next few, right, determine whether the expression is a polynomial, and if so, find the degree of the polynomial. When I look at this, right, this is a polynomial, the highest exponent. So I have 2, constant, 5. So this is a degree 5 polynomial. Anytime you have a square root or variables in a denominator, this is not a polynomial. And the next one, I have x to the 7th, x to the 3rd, minus 2x. This can be a polynomial, and the degree of this would be degree 7. Okay? So the next one, I want you to pause the video and try it. And when we look at it, if we write it in descending order, I'm going to have x to the 9th first. So 12x to the 9th. Then my next exponent would be x to the 5th. So minus 2x to the 5th. Plus 3x to the 3rd. Minus 25x. Plus 6. Remember, if it's positive, we add it. If it's negative, we subtract it. The next one. Start with the highest exponent, which is 12. So we're going to say 9x to the 12th. Then minus 44x to the 8th. Then we have x to the 3rd, so minus 4x to the 3rd. Plus 3x squared. Then plus x, plus x. And then plus 2. This would be the polynomial written in descending order. All right. So which property of polynomials says that the sum of two polynomials is also a polynomial? This would be the closure property. Okay. Under which operations are polynomials closed, right? And if I look at it, we would say division. All right. Now, the area of a rectangular patio is 4x squared. A square garden is built next to the patio. The total area of the patio and the garden is 4x squared plus 9. What does a constant term in the polynomial 4x squared plus 9 represent? If we think about it, we took the area of this patio, and if I look at it, the area of the garden is 9. So the constant term 9 represents the area of the garden. Okay. What does the coefficient of the variable of 4x squared plus 9 mean in terms of the problem? Well, basically the 4 represents basically the length is basically 4 times the width. Okay, so when we find the area of a rectangle, we multiply the length and the width. So it's basically telling us the length is 4 times whatever the width is. Okay, so this should give you enough to get started and try the quiz. If you have any questions, let me know.